Hey everyone, this is Andrew and I have another formation for you. Movement fields are structures that require a specific amount of movement. So if you have two pieces of information, the number of moves and the location, then you're fine. But if you only have one, you can use one to solve the other, no worries. So for starters, you can use any closed shape. I prefer a circle because it has the least amount of area overall. Usually, if they're kind of like the same, if they're put on the same paper. So keys, these show the number of moves, meaning that these can have a number, 1 or 19. Any move works as long as it's in the set of positive integers. So the set is 1, 2, 3, so on. Because if you have 0, then it doesn't really work. Well, it could work, so let's see. Well, prefer positive integers because there's a bit of a mix-up between natural numbers. So, yeah. You can use 1, or you can use 0. It really depends. You shouldn't really. So as for roads, they show the location. Roads are these kinds of separated kind of structures, and if you separate this kind of long structure, then you get bits and pieces. These are called roads. So there's 1, 2, 3, 4, 5, and 6. 6 roads in this one long thing. So now, with these points, or with these bits of jaggedness, we can find the roads, but also the number of points. The number of points is the number of roads plus 1. We have 1, 2, 3, 4, 5, 6, and 7. 7 points with 6 roads. The same works with this kind of structure. Well, there we go. We have 2 roads, so we must have 3 points. It can be curved, it doesn't matter. All it has to do is to show this kind of pattern. And now we can combine all of these together. You don't have to have a stem, but okay, I'm not going to use a stem. It gets a lot more confusing. So we have this right here. And if we have 3, we go from here, 1, 2, and you need one more move, so 3. That's the only possible move. You only end up here. So this is only for 2n plus 1, such that n is in the set of natural numbers. It could include 0. Well, for n, not really this, but for that, if n is 0, then it has to be 1. And the same applies where you go 1, and you're at the same point. Same for even numbers. 1, 2. Just 2n. N is in the set of positive integers. So now, what if we have intersections? This is a bit tricky because you go multiple ways. We have 2. 1, 2, or 2. These are kind of closed. We can use multi-numbers with this point, or okay, point A and B. So we can go A or B. Either way, it's kind of showing the possibilities. Whether you're in A or B, the same pattern has to apply. When we do more of these, you can learn about different types of turning, where one is, and let's see how far we can get with this kind of concept.